Question 7c gives you the mass to charge ratios, the masses of different isotopes, and it also gives you the relative abundances of the isotopes as well. And please note these don't add up to 100, so you need to make sure that you incorporate that into your calculation. Calculate the relative atomic mass of this particular element and give your answer to 1 decimal place. So the first thing we need to do is write down our equation to work out what the relative atomic mass is, and it's the sum of all of the masses multiplied by the abundances divided by total abundance. And if you have a look from the paper, we've got, you can see that one or not? No. We've got 64 times by 12 plus 66 times by 8 plus 67 times by 1 plus 68 times by 6 divided by the total abundance 12, 8, 1 and 6. That adds up to 27. Yep, 27 and 6. You get 1 mark for this, and you get 1 mark for the bottom. That comes out, tap it in your calculator, that comes out as 65.6, and you get 1 mark for that one. And it says if you wanted to, and it might ask you to identify what that actual atom was, then you could have a look on the periodic table to see where 65.6 is, and you'll see that the best fit is this one here. So you would estimate it to be zinc. Part 2, use the periodic table to identify the species responsible for the peak at 64. So that's literally what we've just done. Okay, so the best fit is zinc. So part 2, zinc, and it tells you what the mass is, and it's 64. Now, for this to be picked up, and for this to be measured for abundance, it has to be a charged particle. So for 2 marks you had to say that it was zinc 64, zinc and 64 for 1 mark, and then you got the other mark for showing that there was a charge on that particular species.